In this video, we will be looking at linear equation word problems. By the end of the lesson, you should be able to use linear equations to solve real-world problems. Let's take a look at a few examples. When we're solving a word problem, there's a few things we want to keep in mind. We want to identify the information that we have. So that's reading the problem and figuring out what the problem gives us. Then we want to look at some key terms that are often in some of these problems. For example, we may see the words per and each come up, and what that usually indicates, multiplication. For example, if you see 2 per, it usually means 2x. So that's something we want to look out for. If we have any key terms, we want to, and these are a few of the ones we may see, they typically indicate multiplication. So if you see something like 2 per or 2 and or 2 each, 2 for each, we want to think that that would mean 2x, multiplication. And finally, we want to identify what the question is asking us for. So what are we looking for? What information is this problem trying to get us to solve? So we want to know what we're looking for. So let's look at an example. Nelson is visiting his cousin in Baltimore, Maryland. He needs to rent a taxi to get from his hotel to the National Aquarium. The taxi company charges a flat fee of $3 for using the taxi and 75 cents per mile. Write and solve an equation that represents how many miles it was from the airport to the aquarium if Nelson spent $14.25 on the taxi ride. So notice I highlighted a few things as I read that problem. A flat fee of $3, that may be important. 75 cents per mile, there's that word per we talked about up here. I highlighted how many miles because that's what we're looking for. And he spent a total of $14.25 on the taxi ride. That could be important later. So let's kind of make a list here of what information we have. So we know that there's a flat fee of $3. We know that he spent 75 cents per mile. That's how much the taxi charges. And we know that he spent $14.25 total on the ride. So the key terms we want to look at, the key terms that we noticed here was 75 cents per mile. And what we talked about before, that word per typically means multiplication. So we can go ahead and rewrite this as 0.75x. And finally, what do we need to know? We need to know how many miles. How many miles was it from the airport to the aquarium if he spent this much money? Well, notice here I wrote 0.75 per mile, okay? So my x represent miles, and that's what I need to know. So my x here, there's my miles, and that is what I need to know. So solving for x will get me what I need to know. So now I'm going to set up my equation. So I know that he spent $14.25 total. So that's equaled to the 75 cents per mile plus the $3 flat rate that he has to pay. Now I need to solve for x. So I'm going to subtract 3 from both sides. When I subtract here, I get 11.25 equals, draw my line there, divide both sides by 0.75, They cancel. X is going to be equal to, on your calculator you can do this, 15. What that means in my problem, how many miles? 15 miles. That is the distance from the airport to the aquarium. Let's take a look at another example. Oscar is designing a calendar as a fundraising project for a soccer team. The cost of printing is $50 plus $250 for each calendar. How many calendars does he print if he spent $400? Okay, so again, let's look at the information that we have. Okay, I know it costs $50 for printing. It costs $2.50 each calendar. And he spent $400. Let's look at my key terms. The key term I saw there, if we go back and look at what we talked about, per, and each. Now this isn't a total list. These are just some common ones you might see. So if you see similar words, these are just some examples. So $250 for each. So in my key terms column, $250 for each, which we talked about usually indicates multiplication. So I'm going to write 250x. Finally, what I need to know, I'm asking how many calendars he purchased. Well, when I was writing my key term, it was $250 for each calendar. So X represents calendars. And that's what I need to know. So again, solving for X will tell me how many calendars. So now I'm going to set up my equation. So I know he spent a total of $400 equals $400, 250x plus $50 for printing. Now when I solve, subtract 50 from both sides. Here I get 350 equals 250x. Divide both sides by 250. My x gives me 140. So to answer my question, how many calendars? 140 calendars is what he purchased. Let's look at another example. This one is a little bit different. Not every single word problem is going to follow the pattern that we just looked at. In this problem, we have to translate the verbal language into math. So let's take a look at this. 3 less than 5 times Esmeralda's age is the same as 3 times her age increased by 37. How old is she? So in this case, rather than having have and key terms, we really just we're going to kind of translate this together. So we're going to make one little list. So we know that 3 less than 5 times, I can translate that. So 3 less than 5 times, which is right here. 5 times is 5x. 3 less than 5x minus 3. I know that the phrase is the same as is my equal sign. Is the same as means equals. And lastly, it says 3 times her age increased by 37. So 3 times her age increased by 37. 3 times is 3x. 3 times her age, 3x, increased by 37, plus 37. So I know I have 5x minus 3 equals 3x plus 37. And what I need to know, what I'm looking for, is Esmeralda's age. That's what I want to find out. And Esmeralda's age, that's my x. If we see here, her age. Okay, so when we solve for x, we will be finding out what her age is. So let's go ahead and solve this equation. We have variables on both sides. We want to get the variables all on one side. So I'm going to subtract 3x from both sides. I get 2x minus 3 equals 37, plus 3 to both sides. 2x equals 40. Divide both sides by 2. X is equal to 20. So that means Esmeralda age, she is 20 years old. Now it's time for you to practice some of these word problems. Now remember, not every single word problem is going to follow these exact examples. You want to use all the skills you've been looking at and maybe use other skills like drawing a picture, solving a simpler problem, working backwards, making lists or tables. There's a lot of different strategies you can use to solve these problems. These are just a few examples that we may see.